Example 4. I'll graph negative x minus 2 greater than or equal to 0 or x plus 3 is greater than 6. Domain set of integers. We'll worry about the domain when we get to graphing. Both of these have to be solved before I can work them out. So plus 2. So negative x is greater than or equal to positive 2. I want that to be positive x, so I have to change both signs. Changing signs requires the inequality to switch direction. Equals 2 stays equals 2. X plus 3 greater than 6, move the 3 to the other side. X is greater than 3. Alright, so now we're ready to go. So again, I've got two inequalities. The word or is in between them. And again, anytime you see the word or, it just simply means graph both of them. Graph this one completely, graph that one completely, put them on the same number line. Whatever happens, happens. We're graphing integers only. Less than or equal to negative 2 starts at negative 2, including negative 2. And then only integers going less, so negative 3, negative 4, negative 5. And then we shade the arrow to demonstrate it goes on forever to the left. Graphing every integer as we go. X is greater than 3 with integers. Now, some of you might still be doing this. I can't remember seeing it recently, but I know when we first started doing this, some of you were doing this. You still have this open closed circle mentality when you had integers. All right? Open circles are meant to say, I want to get really close but not include that number. Integers don't have that problem. The first integer that's true, greater than 3, is 4. I don't have to put an open circle at 3 because I don't have to get really, really close to 3. I don't have to include 3.00000001. That's why the open circle would be there. The 3 is not greater than 3. 4 is. That's the first integer that makes that true. 5 is also greater than 3, still an integer. Everything to the right of that looks like an integer is going to be greater than 3 also. Do not put open circles on an integer graph. I only put closed circles. There's always a first integer that makes it true. That's the one you're going to start with. All right. That would be the answer to that. Again, graph the one, graph the other. They both count. And if it's blue, this is true. If it's red, this one's true. If either one of them's true, the whole thing's true. So that's what we're graphing is the truth.